Hi, welcome to our math. Today I'm doing a series of videos on solving systems of equations using row reduction with an augmented matrix. Okay, if I want to solve this with a matrix, I should probably write it as a matrix. So the first thing I'm going to do is I'm going to take each equation and take out the numbers. So my first line has a 5, 5, 5, negative 20. My second line has a 4, 3, 3, negative 6. Then I have a negative 4, a 3, a 3, and a 9. To make this a matrix, I need to put brackets around my numbers, and to make it an augmented, I need to replace my equal sign with a line. I should mention, I don't know why this isn't an X, a Y, and a Z, and this isn't a Z. Half my letters came out wrong. This only works if we have all X's, all Y's, and all Z's. Okay. So what I'm trying to do is I'm trying to make the top row 1, 0, 0, and a number, because that would translate to X equals a number. 0, 1, 0, Y equals a number, 0, 0, 1, Z equals a number, which is an identity matrix. So I want to make these 9 numbers an identity matrix. To do that, I need to get a 1 here. Well, it looks like the easiest way to get this number a 1 is to take row 1 and just divide it by 5. If I do that, I have 1, 1, 1, negative 4. But everything else is going to stay the same. 4, 3, 3, negative 6, negative 4, 3, 3, 9, brackets to make it a matrix, and a line to make it an augmented matrix. Okay. From there, I'm going to do something called pivoting on this number. I'm going to use this 1 to eliminate my other rows. Normally, I would completely do that. I would say that row 2 is row 2 minus 4 times row 1. And row 3 is row 3 plus 4 times row 1. But I could also use row 2 to eliminate this 4 since it's a 4 and a negative 4. So I could just say row 2 plus row 3. Notice I'm putting my row notation next to the row I'm going to replace. All right, so I'm going to take row 2, which is 4, 3, 3, negative 6. I'm going to take negative 4 times row 1, which is negative 4, negative 4, negative 4, and a positive 16. And when I add down, I'm going to get a 0, negative 1, negative 1, and a positive 10. When I add these, they're already lined up. So I'm going to start building my matrix, knowing that adding these, I don't need to rewrite it. So if I build out my matrix, my first row is 1, 1, 1, negative 4. My second row, I'm going to replace with what I just calculated, 0, negative 1, 10. And my last row, I'm going to add. So 4 plus negative 4 is 0. 3 plus 3 is 6. 3 plus 3 is 6. And negative 6 plus 9 is 3. All right, next I'm going to pivot on that negative 1. So what I'm going to do is I'm going to say row 1 plus row 2. And I'm going to say 1/3 row 3, because all these numbers can be divided by 3, plus 2 row 2. All right, so I'm going to bring all my calculations up so we don't lose our original problem. So row 1 is going to be 1, 1, 1, negative 4. And row 2 is 0, negative 1, negative 1, 10. And when I add down, I'm going to get 1, 0, 0, 6. Okay, then I'm going to do 1/3 row 3, which is a 0, 2, 2, 1. And then I'm going to do a 2 times row 2, which is going to give me a 0, negative 2, and 20. And when I add down, I'm going to get 0, 0, 0, 21. Okay, so if I build out my matrix again, I have a 1, 0, 0, 6. I'm going to say negative row 2 here. 0, 1, 1, negative 10, and 0, 0, 0, 21. Because this last line is equivalent to 0 equals 21, which is false, that means that this problem has no solution. If the last row was all zeros, we could do something with it. But the 0 equaling 21 with the false means that we need to come back up to our original problem and say, hey, our original problem is no solution. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.